I'm Matt Yedlin, an associate professor in electrical and computer engineering at the University of British Columbia. Together with Alan Sens of political science, we teach a course on nuclear weapons and arms control. One of the central concepts in that course is the concept of exponential growth. Exponential growth manifests itself in the development of nuclear fission. How can we describe this concept using another example from real life? And the answer is wildfires. In this video, we're going to look at how the speed of wildfires forces us to use the model of exponential growth. A horrific example was the Palisades fire recently in California, where the dry vegetation and the environment and the wind all created a horrible result, with the Palisades being wiped out. How do we explain this phenomenon? So here we have an example of a single house, and the single house has an ember that it's going to launch. It's only going to launch the ember from itself to the next house. So it's what I call a one-to-one development and expansion of the fire. So the first house sends it to the second house. So now we have two fires, and in the next time interval to the third house. So for example, in the graph, after 10 seconds, the horizontal axis is in seconds, and the vertical axis is the number of houses that are on fire. 10 seconds, 10 houses. So 1 house per second gets on fire, and that rate is the same rate, and hence the graph is a straight line. That's too simplistic and doesn't explain the rapid growth we saw in the Palisades fire. To do that, we have to look at the exponential version, which is 1 to many. And in this case, our many is 2 houses. So each house will launch 2 embers. And you can see from the video that the first house will launch 2 embers to 2 houses. Each of those houses will launch 2 embers, and then we'll have 4 on fire, and then 8, and then 16, and so on. In reality, this is also too simplistic, because we have wind that will carry some of the embers to more than 2 houses. It could be 5, so then it would be 5, and then 25, and so on. And that exponentiation, that one-to-many effect, is the basis for exponential growth. Let's tie that back to reality. The CTN News and the references given below has given us a bunch of snapshots of the development of the Palisades fire. And you can see from looking at the frames, it starts very small and then quickly goes to quite a conflagration. That's the real example that motivates our use of exponential growth. In summary, exponential growth, that one-to-many effect, creates a cascade of the final effect. Where can we see it in nature? In fires, in wildfires, in the pandemic, and also, of course, in nuclear fission.